Let's see the derivative of a constant function. A constant function is y equals c. C can be any number. It's a horizontal line. Using the first principles, we know dy over dx is the limit of f of x plus del to x minus f of x over del to x when del to x approaches 0. Since it's a constant function, f of x plus del to x and f of x are both c. So the derivative is 0. The derivative of a constant function is 0. A linear function is y equals mx plus c. Using the first principles, we know dy over dx is the limit of f of x plus del to x minus f of x over del to x when del to x approaches 0. F of x plus del to x is m times x plus del to x plus c. F of x is mx plus c. So the numerator is m times x plus del to x plus c minus mx minus c. This is m del to x. Del to x get cancelled. So the limit is m. Therefore, y dash is m. The derivative of a linear function is its gradient, which is a constant. We already knew the derivative of x squared is 2x. Now let's see how to differentiate x to power n. Again, we use the first principles. F of x plus del to x is x plus del to x to n. So the numerator is x plus del to x to n minus x to n. Using the binomial theorem, we can expand x plus del to x to n to x to n, plus nx to n minus 1 del to x, plus nc to x to n minus 2 del to x squared, plus all the way to del to x to n. The 2x to n get cancelled. Divide by del to x, we get nx to n minus 1, plus nc 2x to n minus 2 del to x, plus nc 3x to n minus 3 del to x squared and so on. When del to x approaches 0, only the first term is kept. Other terms all becomes 0. So the derivative of x to n is n times x to n minus 1. We bring down the power n, and multiply it with x to power minus 1. When we use the binomial theorem, the power n can only be an integer. But this result applies to all real number n. We'll look at some examples next. Differentiate y equals x to 5. We can write either y dash or dy over dx equals. Using the formula, we bring down the power 5, and multiply it with x to 5 minus 1. This is 5x to 4. Differentiate f of u equals u to 6 with respect to u. This time, we write df over du, instead of f dash. We use f dash when it's a function of x. If it's not x, we use the d notation. Using the formula, we know df over du is 6u to 5. Pay attention to the notations here. Now let's look at non-integer powers. Differentiate y equals root x. Root x is x to power half. Bring down the power half. Half minus 1 is minus half. So y dash is half times x to minus half. This is 1 over 2 root x. Differentiate g of t equals t times root t with respect to t. Now let's change it to the power form. T times root t is t to power 3 over 2. So dg over dt is 3 over 2, times t to power half. This is good enough. If you want it, you can go ahead and write it as 3 over 2 root t. There are two rules of differentiation. The derivative of a times f of x is a times the derivative of f of x. Here a is a constant, not a function. For example, y is 3x to 5. A is 3 here. So y dash is 3 times the derivative of x to 5. The derivative of x to 5 is 5x to 4. So y dash is 15x to 4. The derivative of the sum or difference of two functions is the sum or difference of their derivatives. For example, y is x squared plus x cubed plus 5. This is the sum of three functions. We can differentiate them separately and add them together. So y dash is x squared dash, plus x cubed dash, plus 5 dash. This is 2x plus 3x squared. We can also use both rules to differentiate a function. For example, y is 2x cubed minus 3x to 4. Y dash is 2x cubed dash minus 3x to 4 dash. This is 2 times x cubed dash minus 3x to 4 dash. It is 2 times 3x squared minus 3 times 4x cubed, which is 6x squared minus 12x cubed. In this class, we learned the derivative of x to n is n times x to n minus 1. N is any real number. The derivative of a times f of x is a times the derivative of f of x. A is any real number. The derivative of the sum or difference of two functions is the sum or difference of the derivative of these two functions.